So this webinar is going to take an in-depth look at the basics of DNS resolution and resolver caching. And along the way, we'll define some key terminology. The material is coming from the 3-day course, DNS and Bind Fundamentals. It's not from the beginning, but it is basic material covered in the first morning. Very briefly about that course, which we're hoping you'll be interested in attending. Men and Mice Training develops and delivers DNS courses, and we've partnered with the Sunset Learning Institute and have already taught 3 courses at SLI. It isn't official yet, but another will likely take place at SLI's Denver facility beginning December 16th. Keep your eyes open for that. Finally, there are actually 2 courses, DNS Fundamentals, the 3-day, or the more popular DNS and Bind Week, which is 5-day, which incorporates the 3-day DNS and Bind Fundamentals. This is not DNS from 10 or 20 years ago. Everything in these courses, everything we're going to talk about is advanced stuff. Okay, so here we go. Name resolution. Whoops, wrong window. So a DNS query, when you send a piece of data asking for something in DNS, it's in a format called a resource record. And that's always 5 pieces of information. This is the same information for someone who's publishing information, someone who's authoritative for data, or for someone who's consuming information. It's literally the same format on the wire in a DNS message. And the 5 fields are shown here. The first field is the domain name, technically called the owner name when it's being published. We'll skip that for the moment. Just say the domain name. Then the next field is time to live. Then a network class, record type, R type, and then record data. What are those fields? So owner is literally something like a domain name, www.sunsetlearning.com, or I live in Switzerland, gmail.ch for Switzerland, etc. The class of data, for us, we're not going to properly define it. It is always IM. We're always going to be talking about the internet class. Most other classes, there are only 2 that were ever defined, are not at all used. And then a record type, this is what you're looking up. This is what you're interested in. So if we think about the DNS as being, as an analogy, a big phone book for the internet. With a phone book, you think about, well, I have a phone book, I can look up a phone number in the white pages. But you can actually look up more than that. If you were to look up somebody's name, you could look up their address. So we could look up with a phone book 2 different types of data for the same name, David Beck. We could look up the telephone number, or we could look up the type of data, address. With DNS, when you look up a name, a domain name, you can look up all kinds of records, all kinds of different types that could be being published. For example, the most popular type, what people think of first and foremost, is the type that's shown here, an A record. A means an address record. What kind of address? An IPv4 address. So the record data, where the final little question mark is on the right-hand side, is an IP address when this is filled out. Now, by the time we would reach this slide in the course, after 94 slides, this is a 3-second slide. I'm trying to ease us into this a little bit. So why are these 2 fields, TTL, which I did not describe, and record data, blank? Well, when there is a question, which is called a query in DNS, when somebody is asking for something, they know what they're looking up. They're looking up a specific domain name. I'm looking up the phone number for David Beck. I'm looking up for the IP address of www.sunsetlearning.com. I know the domain name. I know the class, it's always IN. I know the type of data I'm looking up. I'm looking up an A record. I'm looking up a phone number. What I don't know is the R data, the record data. I don't know the result of this. So my query leaves that field blank, and the time to live is also left blank, and we'll explain that when we think about what comes back in a second now. A response comes back, and if it's what we call a positive response, then we could also call it an answer. In very accurate DNS technology, just because you get a response, you didn't get an answer. An answer is actually answering your query. So assuming we got a positive response, assuming we got an answer, then what you're going to get back is the query filled out with the record data saying, oh, www. In this case, example.com has the record data 100.75.98.20, or whatever the IP address may be. The time to live is telling the receiver, the person who made the query, the querier, how long this information can remain in the cache. And it's measured in seconds. What's a cache? Well, this is a way of the publisher, which is called an authoritative server, saying, don't ask me that question over and over and over again. If I send you a time to live of 600 seconds, 10 minutes, for 10 minutes, you can trust that information will not change. And you can keep sending it out and keep representing it. Okay. No questions yet? Popping along. So we're going to go through this step by step by step and look at the details. So often well, first we should define what kind of servers exist. There are two kinds of DNS servers. And in the old days, we would put their functionality together. Today, we always want to separate these functionalities. Always is one of 99% rules. In general, you want to keep these two functions separate. And the first functionality is the device shown on the lower left, the device labeled RDNS. This machine is known as a recursor or a resolver. I don't really like the word recursor. I shouldn't have started with that. An RDNS server, a resolver, a smart resolver. Some people simply call it the cache. DNS has a tendency to bury us in words, and there are many, many names for this machine. So I will say resolving DNS server. He does the work for some client, and the client's the machine on the right. We'll get back to that in a second. So the RDNS server, its job is to find out answers, to find out the answers, get results for queries coming from clients. The other three machines shown in the upper right, one labeled with a period, one labeled with com period, and one labeled with example.com.period, those are authoritative servers. Those are publishers of data. They make information available. So let's say, for example, you are the administrator of example.com. Well, the com servers should be able to point to you, and you should publish any information you want in the world you own. You own example.com. And so isn't it recursive DNS server? A recursive DNS server, a resolver, you could simply say recursor, RDNS, all of those names work, cache works. And in fact, if you want a challenge, what you can do is try to make a list of all the different words that can be used for that. I think I have a summary of maybe 20 somewhere, and some of them get confusing. People will start adding words to RDNS or to recursive server or recursive DNS server. There you go, recursive DNS server, recursive server. And they'll add words like pure or solely a recursive server, solely RDNS, purely RDNS. And those words are to make sure that the reader understands that it's not also authoritative, because those are functionalities you want to separate. I hope I answered your question, John. Okay. So, and the machines on the upper right then are authoritative servers. For any one domain, com is an example of a domain, example.com, what we're going to have is we're going to have multiple servers. You don't want to only run with one, but we're only showing one for the example. Okay. So the machine on the lower right here is a client. And the client has used some piece of software. And this is what's really interesting. Almost all software that exists is going to have, that does anything on the internet, is going to have a dependency on DNS. Think of the easiest software, simplest idea you can think of. Think of a simple program like Ping. Ping, you send out an echo request, you get back an echo reply, easiest thing in the world. But if what I typed was ping Microsoft.com, Microsoft.com has to be translated into an IP address, has to be resolved into an IP address. So even ping is dependent on DNS. Now, we could explain, and we do in other parts of these lectures and other parts of the course, how the software, in this case the web browser, talks to a piece of software in the client here. And that piece of software is called a stub resolver. There we can start getting into words that are confusing. On the right, we have a stub resolver, and on the left, we have the resolver our DNS server. Okay, but we're going to skip that here. We're going to say some piece of software, in this case a web browser, went to the domain name www.example.com, and we have to resolve that. It's not shown here, but clearly the query is going to be for an A record, or if this web browser, it prefers IPv6, maybe has a protocol like Happy Eyeballs. If it's a dual stack, somebody can look up about IPv6, Happy Eyeballs. If it's looking up IPv6, then the record type, the R type of data, is not an A record, but it's an A record, which is a quad A, and then the type of data would be an IPv6 address. Okay, whoops, I'm typing in the wrong window. So here we go, and what happens is we get a query, and we see the query is for www.example.com, IN class, A record, the time to live, and the record data are left blank. And here's the query: what is the A resource record, the name of records in DNS resource records? What is the A resource record in the IN class of www.example.com? And the query went out in a DNS message. DNS messages do a lot of work. They send queries, they send responses, they're used for zone transfers, all these advanced things. It's always done in one message. And this query comes in and has one of the flags on, and this flag is called recursion desired. Recursion desired means, hey, our DNS server, I want you to do all the work for me to get an answer. I don't want to just know what you know. I want you to figure out an answer. Please do the recursive work to get a response. Okay. Now, before we go on, I do want to say what I skipped on the previous slide. This RDNS server has an empty cache. An empty cache means he knows nothing. Yeah, it's a little like me. An empty cache means he has no idea what's going on in the world. Is that realistic? No. Normally, a productive server can answer a massive number of queries based on queries he previously asked. At a busy ISP, you might find a RDNS server that's answering 98% or more of its queries from the cache. It might be something lower in your company's RDNS server, but it's still going to be a very high number, high percentage. Why is this cache empty? For explanations. And how do you empty a cache? Or you could restart the RDNS server, but of course there are commands to each server. If you happen to be running a bind server, there's a command rdnc flush. RDNC flush would empty out the cache. Anyway, his cache is empty. So here comes the query. And before we go on, we're going to look at the exact vision of this query with a command called dig. Now, if you want to test DNS, there's a lot of ways you can do it. A very popular tool, unfortunately, for doing is something called NSLookup. And NSLookup is used because people know it and because it shows up. It is delivered with the Microsoft operating system. It's not a great tool. The people who wrote it have long since said, move away from it. They've written other tools, including dig. And dig is, for DNS people, the go-to tool. And if you don't have access to it, I recommend installing it. If you're lucky enough to be running on any kind of a Unix or Linux system, you probably already have dig installed. Unfortunately, it's not always the newest version. And as newer versions come out, they have greater and greater functionality, support new features such as DNS cookies, something we mentioned earlier. That's going to be our webinar at 1 o'clock. Okay, so in green at the top, we see a command dig plus QR. Options to dig are often with plus signs. Plus QR says, show me the query. Normally, dig only shows a final response. Doesn't show the query that was sent, doesn't show all the work in getting it if it had to make multiple queries. Yeah. So we want to see the query itself. The next option here is plus no eDNS. What is that? eDNS is extended DNS. Since 1999, we have a way of making DNS have extra features covered heavily in the course. For the moment, I'm trying to avoid those features so we don't see things in this simple output right here, such as cookies. Yeah, okay. And there we go. The beginning dig is, and there we see the query. Dig plus QR plus no EDNS, www.example.com. I didn't tell it the type to query, but it defaults to A records, and I didn't tell it the class, it defaults to IN, internet class. And there we see the query behind all these semicolons. Dig explains that he's version 9.11.0RC1, and then we see sending. And then we see a DNS header, and the opcode is query. We look at the header in great detail in the courses, and status, which in the header is actually called R code, response code, no error. Well, at least we didn't get an error, that's good. The next field here is the identity in the query that was sent out, the ID, also known as the QID for query ID or TXID for transaction ID, is a way that the querier can associate a response coming back from a server that it's sent to. It's also the closest thing we have to a security feature in standard DNS. Flags. The only flag in the query was RD. Hey, our DNS server that I'm sending to, I want you to do recursion. And then there are 4 sections in a standard query. And in this, we had one query. There were no answers in what we sent, which makes sense in our query. And there was nothing in the authoritative or additional section. Point is, we had a very simple query. And the query, known as the question section, is www.example.com INA. So really on the wire, Dig is showing us what was really in the data. We see exactly what we expected. And if you go, and the query was 33 bytes, and as you go further down, got answer, that's what you would normally see if we hadn't used this plus QR flag. We would see only a response. Okay, answer, response. There we go. So now, what happens over at the RDNS server? The RDNS server says, oh, I've checked my cache for the answer, or I've looked for a referral that would help, but it's empty. Okay, what is a referral? Referral means I already know some information. I don't know the final answer, but I might know how to get to the final answer. We'll take a look at that later. But if, for example, the server, the RDNS server, already knew how to get to the COM servers, already knew how to get to example.com, but didn't have the answer, he could use that information. That's called a referral, okay? So the only thing that this RDNS server can do is query one of the root servers. Root is the top of the DNS tree, and there are 13 root servers, brilliantly named a.rootservers.net, all the way up to M. Yes, M is the 13th letter of the alphabet. The RDNS server is pre-configured with the names and IP addresses of those servers. So at this point, he's going to choose, for our understanding, randomly, but the truth is he'll probably do something far more intelligent than that. He's going to choose one of those 13 servers, and he's going to send the query, the same query. The header will be a little different to one of those servers, to one of the root servers. Here we go. There's the query, same query, www.example.com, IN, A. It says the same question. What is the A resource record in the IN class of www.example.com? But look at the RD flag here. The RD flag is off. It's cleared. He doesn't want recursion. If this root server that he's sending to was willing to do recursion and go and figure out an answer, he doesn't want him to do that. He just wants to know, the RDNS server just wants to know what the root server knows. Now, the root server wouldn't do recursion anyway, but just to be clear. So even though the work that the RDNS server is now doing is called recursion, this query without the recursion desired flag on is known as an iterative query. Just give me an answer. So what happens? This server is what we call a purely authoritative server. So he doesn't have a cache. He doesn't work like an RDNS server. So there's no cache, so he can't answer from a cache. Well, next thing goes, well, Am I authoritative for the example.com domain? Well, no, I'm not, so I don't know the answer. Well, maybe I have a delegation that points to example.com. Delegation is the idea I point to another server. I say, I don't know the answer, but I can send you to another server in a waterfall type way from root going down. But root looks around and he goes, I don't have a delegation for example.com either. So on his first three things that he could have been able to handle this himself, he can't. He's not authoritative for the data. He doesn't have the answer, and he doesn't have an example to example.com. So he works his way up a level from example.com to com, and he goes, oh, wait, I do have a delegation for com. I know where the com servers are. I can point the RDNS server to the right next place to ask. So I will not send an answer, but I will send a response, and in that response, I will send the delegation that I have. When I'm sending it, it's called a referral. So delegation is what I have. When it's being sent to the other, we're sending a referral. So referral. Here is a list, not in the answer section, but in a section called the authoritative section of the DNS message of all the servers that are authoritative for com. Now, we have some words here and some concepts here that come early in the course that we're going to kind of not define in detail, but what we'll say is authoritative section. When we were looking at the dig, there were 4 different sections. There was the query, answer, authoritative, and additional section. So authoritative section, this is not what you asked for, but I'm going to give you information that is useful. I am sending you to the authoritative servers of com. How do I provide those? Well, I don't send an A record. What I send is another kind of record. And those records are called NS records, name server records. So I send all the NS resource records that point to the com servers, that list the com servers. And maybe there's 1, definitely not 1. Maybe there's 50, it's not 50. I think for com servers, just like root, there happens to also be 13 for historical reasons. So the RDNS server gets this list of 13 NS resource records to go and ask. Okay. So he's going to take that information and he's going to put it into his cache. When the root server sent it back, it came with a time to live. Maybe that time to live was 3,600 seconds, 1 hour. So for the 3,600 seconds, he's not going to have to look up something in the com domain. He'll be able to go straight to the com servers. Okay, so that's storing it for the future, helping for another query. Doesn't help us now, but he takes one of those servers that came back, chooses one of them, and he sends the same exact query that he sent to the root server again, an iterative query, RD equals 0, recursion is not desired. He sends it again to one of the 13 com servers. 13 com servers, what happens here? He looks around, he goes, well, I'm a purely authoritative server. I don't have a cache, so I don't have an answer in a cache. I am not authoritative for example.com, so I don't have the answer myself. I am authoritative for com, and I happen to have a delegation for example.com. I know where the example.com servers are. I will send that delegation instead of an answer. There we go. Same story again. We get another referral being sent. The delegation is a referral, and another list of NS resource records, this time for example.com. Here's the list of servers that someone should ask for example.com. What does the RDNS server do? Puts it in this cache. Cache is the delegation information for example.com for whatever time the authoritative server said he's allowed to cache it for. It's a decision from the authoritative server, not a decision from the RDNS server how long something is cached. And then he chooses one of those servers from example.com. Maybe there's 4, chooses one of those 4, sends the query there. It's the exact same query sent to the root server, exact same query sent to the com server. And the example.com server says, wait a second, I am actually authoritative for example.com. I know the A resource record for dub, and I'll send it. Now, before we go on, let's think about this. What happens if he doesn't have an answer? He goes, I'm authoritative for example.com, and there is no record www. Well, then he can say authoritatively that it doesn't exist. He can say as a fact that a record, www.example.com, doesn't exist. Not the same answer that root gave or com gave. Com and root didn't know if it existed or not. They said, go ask somewhere else. The example.com server could explicitly say, I don't have it. And therefore, it does not exist. And then he has two ways of saying that. It depends if the whole name doesn't exist. If the whole name www.example.com doesn't exist, then what he sends back is a response that's called an NX domain, non-existing domain name. The other possibility is maybe the name www.example.com exists, but there's no A record. So you can't say NX domain, name doesn't exist. It does exist. The name exists, but the type doesn't exist. In that case, the server sends back something we call no error, no answer, or no error, no data. That's a little more detailed than we're aiming at right at the moment. Just to comment on the group chat, John said something that's correct. He said, an NS record means go ask one of these guys. Well, what's interesting about the NS records, and that's what I was explaining, NS record means here is a way to go somewhere else. Here is a delegation. I used to be responsible for everything under com, but I have delegated part of it away. I have said stuff for example.com I'm putting over on these people on these servers. But what's strange about the NS record, or kind of interesting about the NS record, is it has two functionalities. That's the first functionality. The second functionality is for our zone itself, example.com, to state which servers it has. And if anybody knows anything about database design, anything about standard designs of relational databases, there's a good rule. Never, ever, ever put data in two places. Never put the same data in two places. So if you have a big list of users, Dave Beck is one of the users, and then you have the list of users, but you also have a list of people that owe money. You also have a list of people in classes. You also have a list of people with parking spots. You're not going to list Dave Beck in all of those places. You'll make a separate table with just users, and all of those other things will point to the one existence of Dave Beck. And this way, if a name changes or a phone number changes or anything related to that person changes, you only have to change it in one place. That was a little off on the side. Where was I going? Well, the NS records are a violation of good database design. NS records are both in the parent domain, com, for example, and in example.com. And they should be exactly the same. And of course, people make mistakes. Things change. And then you have problems in your DNS. Problems like lame delegation. We talk about all those sorts of things in another course. So for the moment, we talk about the NS records for delegation, but they have the second functionality of being the official authoritative list of servers. Okay, back to it. So let's skip the side discussion, excuse me, of if the answer did not exist. In this case, it existed. The example.com authoritative server said, I'm authoritative, and there is an answer. So he sends back, as soon as I click in the right window, an answer. Okay. Here, for the first time in the answer section, we get, there it is, an answer. And the answer is www.example.com, a time to live, in this case, 86,400 seconds, which is 1 day. And we have the IP address 93.184.216.34. What does the RDNS server do? He's going to cache it. For the next 24 hours, if anybody asks him the exact same query, he's going to answer it straight out of his cache. That has the advantage of speed. The next person, the next system asking for the same record will get a faster response. It has the advantage of less network traffic. We're not going to keep sending out the same queries. That's the biggest original goal of the time to live, that we don't generate so much network traffic. And then it has one disadvantage. What happens if the human beings who are authoritative for example.com, who have the responsibility for example.com, what happens if they go and change the www.example.com A record? They put a new IP address in there. They've put it on the new server. Well, for 24 hours, this RDNS server is going to be providing the old information. Is that a problem? No, the people who are authoritative for that zone said it was okay to cache that information for 24 hours. They need to know that if they're going to change it, they need to make the change slowly over 24 hours or drop the time to live. And there's a variety of ways to deal with that issue. But it's just an interesting point, yeah? So knowing your time to lives and knowing what to do with them is important, yeah? And the idea of using very low time to live so you can change anything you want, that's inefficient. Don't forget, people are trying to access something that you're publishing. In this case, your website of your company called example.com. And you want that to be as quickly as possible. So having caches know it is to your advantage. Anyway, the RDNS server has an answer finally. The RDNS server has cached the answer. And the RDNS now sends the answer to the client. Remember the client about 20 minutes ago was making this query? He's been waiting. It doesn't take 20 minutes, but he's been waiting. And it comes in and it lands in the stub resolver of the client. The client can then pass the answer up to the piece of software, in this case, the browser. Okay, and we have another question here. Can Dig show referral from a .com DNS service? Yes, but you, good question. You would have to explicitly query it. So you would have to figure out what the NS records are for .com, and then you would have to query one of those servers asking for those records. If we have time, I can do that at the end, show an example of that. And so it would take 2 or 3 little steps, but absolutely you can do that. Additionally to that, Dig has an option called plus trace. And the plus trace option has Dig work differently than when it is doing a normal query. Dig ignores the RDNS server effectively, and it pretends it is an RDNS server itself without any cache. And it will then first query the root servers, get the referrals back, then query, in this case, the COM servers, get the referrals back. So you would see all of the steps using Dig plus trace. Okay. Hope that answered the question. Oops. And the very happy client here has been able to load his document. Okay, so recursive versus iterative query, the stub resolver, the client, and client's a lousy word, although we use it all the time, because this machine on the right-hand side is a client of the RDNS server. But the RDNS server is a client of all of the authoritative servers. And if you want to know that you've reached a certain level of skill in the DNS world, sometimes you'll read a document or you'll read an email in one of the DNS news groups and you won't understand it. And sometimes it's because you don't understand it, but sometimes you look at it and say, I don't understand this because the person writing it is not being clear enough. They're simply using the word DNS server, and you can't figure out if they mean authoritative or RDNS or both. And sometimes you have to read quite a bit before you can realize what they had meant up above. Anyway, so the client here sent out one query and requested recursion. That was a recursive query. The RDNS server sent 3 iterative queries during his recursive process, and recursion was off for all those iterative queries. Each of the authoritative servers provided one response. Only the final response had another flag in the header called an AA flag. And the AA flag is the authoritative answer flag. So earlier in the course, we talk about every little bit and byte in a DNS message, including all the flags. What's authoritative answer? I am in charge of this data. This is official authoritative data. A normal stub resolver client making a normal query to an RDNS server will not see an AA flag because the RDNS server is not actually authoritative for anything. The other point about this that we can use the AA flag to discuss is that the referrals from the root server and from the COM server were not with the AA flag on. They were not authoritative for those NS records that were sent. Where do you find the authoritative NS records for example.com? In the example.com servers. They have authoritative answers. COM only has a delegation, which is not authoritative. And if you get into DNSSEC, that plays a role as well. For the moment, we'll move on from that. So, recursive query, iterative queries. So we had a little quiz question here, and there's lots of these in the course. The course, actually, what I should have mentioned, is actually full of labs. You spend a massive amount of time doing labs on your own servers, but in this chat, we have a couple little quizzes. And non-delegated TLD, oh God, what does all this mean? TLD, top-level domain, when we talk about com, org, net, or if you're in Germany, DE, if you're in the UK, .UK, France, .fr, all of those first labels that you see on the right-hand side is the top-level domain. Well, there are corporations that want to have DNS data that they don't publish to the outside world. So they want to have authoritative servers inside their company that provide information only inside the company. Lots of companies, many, if not most companies want to do something like that. One poor choice of a way of doing it is to use some specially made up top-level domain. .corp, .corp is popular. .lan is sometimes used, yeah? .internal, whatever stupid names say, oh, this is my name, it doesn't really exist in the internet. Well, what's the problem with doing that? Well, let's imagine you go and your stub resolver client web browser goes to www.intranet.corp, www, whatever internal thing you want, .corp. And that goes over to the RDNS server. The RDNS server is going to look in its cache. If it doesn't have an answer in its cache, under normal resolution, it's going to look to see if it has a referral. And if it doesn't, it's going to look for the name corp. If it doesn't have that either, where's it going to send this query? All the way to the root servers. So if this query goes to the root servers and the TLD corp doesn't exist, then the root servers are going to send back NX domain, non-existing domain. So why does this work so well in so many companies? Because companies do special things on their RDNS servers, either making them authoritative for corp or having special pointers called forwarding or stubs, forwarding zones or stub zones, where they point to those servers. Things work out just fine right at the beginning, and over a bit of time, things are not maintained as well as they could be, and things go south. a massive, massive, massive number of queries that arrive at the root cannot be answered by the root. The fourth, maybe fifth most popular top-level domain that gets queried, I think, is home. It's not delegated. Land, corp, they're all in the top 20. So a massive number of things are leaving networks to places that they were never meant to go. Are there proper ways to do this? Yes. Are there good ways to have internal networks without having these problems? Yes. Can't talk about them right now, but know that they're out there. Okay. Second little piece of this, tying it all together, caching. So continuing right along where we were, the RDNS server has NS records for the com, NS records for the example.com zone, and has the actual A records for www.example.com. Now, all of those are in there with time to lives, and the seconds are ticking down until that information can no longer be used. But at the moment, that's all in there, and the time to lives have not hit 0. Time goes by, and another client sends another query, and the query this time is going to be for the A record of ftp.example.com. Same exact story as before. Recursive query, rd flag equals 1, arrives over at the RDNS server. Hey, what's the answer? RDNS server is going to look in his cache. Does he have an A record for ftp.example.com? Nope. But he doesn't have to send it all the way to the root. He knows where the authoritative servers for example.com are. And he will choose one of those authoritative servers and send it to there. And we had said randomly there were 4 authoritative servers for example.com. For the very first one, he may have chosen randomly, but over time, he's going to start making intelligent choices to get the best speed, to find the fastest of those servers outside of the scope of what we're discussing. So RDNS server, I don't have an answer. It's not in the cache. However, I know the authoritative servers for example.com, so I will send the query straight there. Things are going to happen more quickly than when we looked up www. And what is the A record for the what is the A resource record of FTP example.com? Recursion is not desired. Iterative query. Not only a response, but an answer in the answer section. He's going to cache that answer as well and provide an answer in the answer section again for the client. And we have a happy client. Oh, another little quiz question. So this one makes more sense to do with a live audience, but at this point, even you guys, I think we should be able to answer this. What is the time to live value in resource records? Second, a packet with this resource record is allowed to be forwarded. Seconds, the resource record is allowed to be stored in a recursive server's cache. Days, the resource record is valid in the internet. And the answer is how many seconds the resource record is allowed to be stored in an RDNS server's cache. Okay. So that was the heart of this little piece. And I would like to show you the referrals from the com server. There we go. I'm just going to log into another server where I have a better DNS system set up. And what I'm going to do is I'm going to try and find from the com server's delegation, and let's use Sunset Learning as an example. So I'm going to send a dig. First, I need to find the NS records. Dig for the NS records. By default, it would have asked for the A records of the com servers. What are the NS records of com servers? And we get back a list of 13 names. And that's the answer section. It was the answer to my query. And then in the additional section, That was the fourth section, a section I haven't talked about. It gave me some extra help. It said, hey, I also know the IP addresses, IPv4A and Quad A records. Doesn't matter. I'm going to randomly choose one of these. I'll choose B for no good reason. And what I'm going to do is I'm going to send a query to one of those servers, the B server, and I'm going to ask it for the NS records of sunsetlearning.com. Now, before I send it, what Dig does by default is it assumes it's talking to a recursive server, to an RDNS server. And we don't really want to send a recursive query. We want to send to this server, this authoritative server, a non-recursive query. So I'm going to go to the beginning. I'm going to say plus no recurse. I could have shortened that. And sending to the B server, asking for the NS records of sunsetlearning.com. And that's going to scroll off my screen, so I'll type into more. And the excitement's not really there because I hit return and nothing coming. Oh, there we go. I didn't hit return. And what do we have here? We have in the authoritative section, the NS records for sunsetlearning.com. And this is WorldNIC. That's who's providing the DNS for Sunset Learning. So if we go all the way back to the top of this, there is not an answer. We don't have an answer. Yeah. Instead, we have a referral. So this is the answer to the question that was asked earlier. Can we see delegation? When it's sent, can we see a referral? And we do. We see sunsetlearning.com. There are two servers. They have the same time to live. And because this is a referral, it is not an authoritative answer. And if we look at the flags that are on, we do not see the AA flag. I don't remember who asked the question. Oh, can Dig show referrals from .com to DNS servers? Well, that's exactly what it is. So Piasat, that's the answer to the question. While we're at it, as we said, there are two different servers that have the same information. One is the parent, which in this case is the COM server we just sent to. And the other one is the zone itself, the servers itself for Sunset Learning. What are their servers? NS31 and NS32. And if we were to send the exact same query, I'm going to repeat it here, and I'm just going to change the server. I could just type the IP address here. That'll work just as well. But I'm going to change the server to send it to, I could have left this fully qualified, period's fine there. I'm going to change the server to send it to an authoritative server for that zone, sunsetlearning.com. And we get back the exact same answers, which is really good. You want consistency between you and your parent. It's bad that we have this system where we're publishing information in two places, but if you're going to do that, you want it to be the same. What do we see in the data? Anyone want to type the answer here? That shows us this is different. What is different about this? How do we know this is, well, what do we see that's different? We'll leave it at that for the moment. Bill, excellent. So we see that we have the AA flag, meaning it's authoritative answer. There's a second way to notice a change. If we scroll up, the response that came back from the COM server had no answer in it. It had a referral in it in the authoritative section. But the answer, the response from the sunsetlearning.com server says, I am giving you an authoritative answer, and it is actually an answer. So here it is in the answer section. So slight difference, other than that, same information. The idea that their time to lives are inconsistent is not ideal. That's probably something that should be fixed. There are worse problems in the world, but it would be better if they were the same. It would be much worse if the name servers were different. So while waiting to see if any other questions come in, I will show you quickly one other, just about the courses, about things we could talk about. Don't forget, in another hour from now, we're going to have a more advanced session on DNS cookies. And I'm just going to swing over here to the Sunset Learning website. And when you're on Sunset Learning, if you go to Course by Technology and you click on DNS and Bind, there are other ways to find this. You will see DNS and Bind Fundamentals, DNS and Bind Advanced. Advanced is the last 2 days of the DNS and Bind week. So DNS and Bind week, 5 days, first 3 of which is fundamentals, advanced the last 2 days. We generally do not recommend people take the advanced course without attending the fundamentals course. Even for people with years of experience, we find that they get a lot out of fundamentals. To be honest, the names fundamentals and advanced are not wonderful. Well, particularly advanced is not wonderful. I would describe the advanced course as the next 2 days of fundamentals. It's still the heart of DNS. What it is not is esoteric garbage, stuff that, oh, because DNS has existed 30 plus years. There's lots of things in there that no one uses and are not of interest. That is not what any of this is about. Anyway, if you clicked over to DNS and Bind Week, you would see the courses. What you will not see yet is a schedule of the next date available, but the next course will be unofficially now starting on, I think it's December 16th in Centennial near Denver. And that's it. I hope everyone enjoyed this. I'm going to close out the chat, and I'll see you all, or many of you, I hope, in an hour. Thanks, guys.